We will get started for chapter 3. We totally have about 14 chapters. In this chapter, we will be working on the input and the output. And then before we work on the input and output, we need to know about what is class. And the class is a program unit in Java. So a minimum class that you can create is like this: class and then space A and then left right curly braces. So it's totally 8 symbols. And this one is a legal program. You click compile, no problem, right? It's no problem. And then I can create another one called test A, right? And this test A, well, I get rid of this garbage. And this test A is a program. And this one this one come with public static void main, and then that is okay. So this one compile, it pass, right? And this one you can compile, but you cannot run. It's okay to write something like A, but you cannot run because right now you don't have the main program. So this one right now is a pure data class, and this one is a driver class that has the main function. So these two, there's a difference. The A program is called a data class. So A is data class, and this test A, you can call it a driver class, or you can call it tester class. Basically, you use that to test someone else. Okay, so here is a data class and a driver class. And driver class, at least you need to have this public static void main, string bracket arguments. So this is a minimum data driver class. And A is the minimum data class. Now let me clean it, okay? And then right here, this program I compile, it actually passed. And let me run it. It ran, but nothing has happened because we are not printing out anything. So that's a minimum program that can be run. And A is a minimum program that you can actually write. And that's a data class. Now, let's look at the difference. Here, this one I can write. Actually, I can have this A, small a equals new A, that is. And this A actually means this A right here. This, we are creating an object. This one I call it an object A. So A is an object right here. And this object, little a, actually is of A type. So here I write down this A, first A is actually A class. Second A is a variable name called A. So it's a reference variable name called A. And then equals new. New means create an object. And create what object? You create an A object. And A object is this A right here. So after I compile this one, my program right here, the test A has a link to it. So this one actually means use. So test A use a data class. It's use function. This one means use. Okay, an arrow and some dash line, that means use. So test A use A. So this one has the relationship of test use. So test A actually create an object called A and then use it. And this is of no use because my A has nothing in there. So right here, let me put something. If I say this is not A class, I put it as pointer class. So each point I have integer X and integer Y because this is a 2D coordinate. So I have coordinate X and Y. right? I set it up as a coordinate, and I have x and y. But here, the constructor, this one I change it, and it no longer has the A class. So now I need to change it to point. So then test A continue to use point. But inside here, I have a x and y, right? And then right here, I can actually say my point is point, and then here integer x and integer y, right? No, let me say this. This one A and this one B, right? And then I say x equals A, y equals B, right? Something like that. And I want to calculate the distance. So I say double, and then distance, and then right here, the distance of the point xy. So it's the point, let me say double slash point x and y to 0, 0, right? So the distance of point xy to original point, what is the distance for this one? It's actually square root of x minus 0 square plus square root, square of y minus 0 and test square root. So it's something like this. I have a point called x and y, and original point 0, 0, and this is x, this is y, this is square root x squared plus y squared, right? Mm-hmm. So that is the distance. So I create a function called distance, and this distance actually I need to do what? I need to create a distance value. So here is a double type, so I say return and mass.sqrt square root. So mass is another class, and mass is called utility class. And this utility class, actually, you can basically provide all the function that is square root or power. So it provides square root of something, some number, or you provide power. It actually, this power means 2 to the power 3. So this one actually equals 8. Okay, if I write POW, power, I actually mean power. 2 is the base, 3 is the power. So 2 cap 3 is 2 to the power 3, and then it would be 2 by 2 by 2. That's actually 8. So that actually is another function called power. And this one is called square root. Square root, you are taking square root of the content in here. And the square root, what I want to do is like x times x plus y times y, right? So that becomes the distance. So here I set the data, I assign A to X and assign Y to AB to Y, and then I calculate, I can have a distance to calculate it, and let me compile it. So right here, I'm missing something, so let me put 0.2 and 3 into here, and I compile. It passed now, right? Then next thing I want to do is system.out.println, and I say a.distance. So A is at a point. A is the point, and what point A is? A is the point. A is this point. A right here is this point, X and Y. And right now I assign 2 and 3 to there. And here is 0, 0. So when I say A.distance, actually is calling the function, distance function inside my point. So actually for my A is actually a point, and then I call this distance function. So let me do this. Let me increase the font, make it bigger for you to read more. easier to read. Okay, so I actually, that point A actually, that distance means calculate its distance, and its distance is calculated based on x times x plus y times y. So that actually give you the distance of this A point to 0, 0. Okay, and then I compile, and then I actually print it. So 2 and 3 right here, so something that's not easy to read. Let me put in 3 and 4. So if I have a point 3 and 4, what would be the distance?
5.
Yeah, so that would be 5. Right? I got a 5 over here. So here is a basic system. I have a class. So right here, how many class we involve? One class called point, another class called test A, the two class. Third class, we have a system.out. System is another class. And we have mass class. So totally we have 4 classes involved. Okay. So here we have point class, that's data class. This one's data class. We have test A class. This one's the driver class or tester class. We have mass class, that's utility class. Utility means it's function for people to call. And last one is actually system class. Last one is system.out. So system class is another class called is also another class. So system class is another class, and this system class is another utility class. It provides function for people to use. So there are 3 kinds of class: driver class, data class, utility class. Okay, and then we had show you 3 different classes. And right here, the system class. So we have been using system.out.println for a while, but you might not have the thought about what it means. System is a class that provides methods related to system. So it's actually, system class is a system environment class, and it provides function for people to use. So when it provides function for people to use, we call it utility class. So it is helping other people to do something. And then system.out is a special value that actually additional function that println. So the function actually being used is println, or print, sometimes print. So basically, these are the description for system. And then you can actually print out system.out, or you can even print out system.in. And those two are 2 different data structure called what we call it as test string. So let me create another class. Here, let me create another class called test system. Okay, here's another class called test system. Let me remove the garbage. And let me copy over the basic things over here. And inside here, I don't need this data. And here, actually, I type in system.out, and I can copy. And I can also type system.in. So system.out and system.in are 2 data. What kind of data they are? We actually look at this. Okay, one is a print string. One is a Blu-ray input string. So what did this means? So system.in is a string, input string. So basically you have a keyboard. You have keyboard right here. and then you provide a lot of text like A, B, C, whatever into your computer. So this is a scanner. And then to your program, your main program is read from the scanner, say input the next line or something, right? After you do some calculation, you say system that out the print. So you actually send the print out. You actually send the print out. You send the print out to the monitor, to the screen, all right here, print over there. Okay, so this part is called input. This part is called output. And your system.in actually means keyboard. System.in actually means keyboard. Right? System.out actually means your monitor or your screen. Is that okay? So one part is input, the other part is output, and system.in is your keyboard, system.out is your screen. So right here, let's go back to our test A. I have a 3, 4, and I want to print out the distance. So right here, let me put import java.utility. I call it utility function class. So it's a utility scanner. So scanner is a utility class. And I say scanner input equals new scanner. System.in, right? And right here, I say system that let me see integer. Let me see. I have x. I'm sorry. X equals s0 equals input that int. Input that pass. I'm sorry. Next integer. Okay, and before I read in that, I should say standard out the print, and then right here I enter x. Okay, and then I repeat again. And then here I say input y, and here I say y not, y0. Okay, and now here I put x0, y0, and I calculate the distance. Okay, now let me compile and run. So it asks for x coordinate. Let me put 3, y coordinate. Let me put 4. Then the distance is 5. So here I can say and I compile again and run. And 3 and 4, right? So basically, this complete what? Complete my function of reading in from keyboard using scanner and then put into my program. And I do some calculation here. After I finish, print out to the system.out, that's actually my monitor, and then print on my terminal over here. Right? I complete these things. And that's test A. And now, if I don't want to read from my keyboard, right? Here I have this system.in is system.out is a print string. It's a print actually print string. So actually here is a java.io the print string. And then keyboard scanner actually is a bj input string. Okay, system.in is the input string. So here we have those numbers are the edges of system.out and system.in. So one number, this number are the port number for IO. System.out the package. So it's actually the package is java.io. It's related to IO and stand for input and output. And system.out actually is assigning the edges to system.out. So basically, you try to print the data through to the monitor through these edges. Okay, so I have a hello.java, and then it call this system.java, and then print string.java to print out my string to monitor. So the next one is a scanner class. Scanner class accept input strings. So system.in is a keyboard input string, and there are some other input string. So you actually need to import java.util.scanner, and the scanner actually read in is put into the java.util. That's a utility package, and you read in data from that keyboard and then put to the scanner, and scanner actually process with the next integer. So each time you read in the integer for you. Okay, now actually here I have a program that's wrong. So it asks us to type something. So I type user, right? Right? So this is input and output. And now, these are I read in from keyboard. So my language element from big and to small. The smallest one is called token. What is a token? A token is, let me bring up the program. So what is a token? A token is a basic words in Java language. So this guy pointer is a token. A is a token. Equal is a token. New is a token. Point is a token. Parenthesis is a token. X0 is a token. Comma is a token. Y is a token. And then parenthesis is a token. Semicolon is a token. So each of the logical unit, minimum logical unit is called token. And what is the expression? This one is an expression. Integer A equals X plus Y. This one is an expression. And then this whole thing is called statement, the third unit. And this is actually statement. This actually integer A is actually a whole statement. This one not here, okay? It's actually the big one is a statement. And then what is a function? A function is this static is a function, and then bigger one is a class. And the whole upper level is called a package that you actually call java.util or java.io. So these are the hierarchy or the program unit, a size of the program unit for a program in Java. Okay, so right here you have detailed explanation of the tokens, and then public means the class is visible by other class, and then right here there are a few words. Now we will stop right here, not going to this literal and constants. We are about here. Let me show you another thing. Right here I show you I'm reading in from from my keyboard and print out to my screen. Now I don't want to do that. Now I want to test file. If I don't want to read the data from my keyboard, I want to read it from file. How should I do that? Actually, this one, the util.scanner, and then import java.io.file, something like this. Okay, so here I would say public static void main string bracket args, something like this. So here I say scanner input equals new scanner and put something like this. I haven't decided what to import. So here I say file. So here is like AA equals new file. And then here I put the name AA.text. So here I put AA over here. In AA. Okay, here I need to handle exceptions. So right here, that means throws exception. When you work on a file, you need to do that. Okay, so I'm trying to open the file called AA.text, and then I try to read in from that file. You know, in the past I used the system in as the input, but right here, instead of using the reading from file, so usually I read from keyboard, and then put into the scanner input, and then put into my program. Now I don't want to do that. I don't read it from my file called AA.text, and read into a scanner, and then get into my file. So I don't want to do the same thing I did before. Now, where should I go? I should go to this files directory. So I'm going to C drive, and then Eric, EC Learning, AP Review, and then J. Oh, no, sorry, I get to the wrong one. I should go to EC Learning, this one, and for Ashley, J, chapter 3. Over here, I have the point, I have the test A, I have the test file, I have test system. So here, I create another new file that actually is AA.text, right? And I open it. Here, let me type alpha, beta, gamma, delta, epsilon, and phi. Okay, it's A, B, C, D, E, F in Greeks, right? I finished that. And then let me close this one. In here, I open the file AA.text, and I put a AA.text over there now. So I do this while input that has next. Do the following thing. Each time I try to use like string token equals input the next line. I read the token in, and then I print it out to my screen. I read out the string, and then I print that out. And after I finish this printing, right here I put input.close. So I close the input string. And I compile, and I run. Let me see something wrong here. File not found. You cannot find the file. So where did I put that? I have the test file. So where did I put that? Oh, I make a mistake. Actually, this is text AA.text, right? But it's actually not AA.text. It's AA.text.text. So let me actually show you the property. It's actually AA.text, but it actually is a text file. So I write this text twice. So now I say okay. So it began with AA.txt, but it doesn't show the AA.txt. So I compile and then run again. Okay, let me clean this window first and then run again. So output is like alpha, beta, gamma, delta, epsilon, and phi. Now, what this file actually complete? This file actually has a keyboard, Oh no, this is not keyboard. Actually, it's a file called aa.txt. It opened by this and then fit into a input scanner and then input into my program. And my program each time, if the input string has something, I keep reading one line and then print out that line and print the line to the monitor. And then it keep checking until the file has nothing, I get out. And once I get out, I actually call this input close, the close. So this one I actually close it after I finish. But I already did read out the data from here to here and put it out. Is that okay? So basically I changed from keyboard input to a file input. So right here, if I don't like these, I deleted all of them. Oh no, this one I cannot edit it, I'm sorry. So I should edit from here. So I open this, I edit this. I say uno, dos, tres, cuatro, cinco, whatever. It's Spanish 1, 2, 3, 4, 5. Now I compile again. Actually, I don't need to compile. This is the same program. I just read it. Right? Let me clean this. Right? Uno, tres, tres. And if I don't like it, I just modify it right away. I can still print up this one. I don't like it. 1, 2, 3, 4, 5, 6. Okay, what's that? Why is this 1, 2, 3, 4?
I don't know.
It's Japanese, Nihongo. Okay, and then you print that. I mean, I just add the system that out the print line, no print, and then I should put /f. So I can always modify the file and then run, right? And here I just want to show you if I continue, cg art cool Jew, right? I'm modifying on the fly, right? And then I don't need to compile. I just change the data file. I just run it once, it changed, right? So I continue Juni. I don't actually, I just save my data file. I don't need to change my program. I run it now, right? 10, 11, 12. Oh, get it now, right? That's the function that I actually read in from a file. I actually read it line by line. Each time I check if there's another line, and I read in, and then that line I actually print it out right away. And after I print out, I say close, right? But this one actually is from keyboard, from file to monitor, right? Now, I don't want to do from file to monitor. I want to have test file too. I don't want to do that. And I put it here, right? And then I delete, I mean, just copy from test file. Copy everything. And I overwrite everything over here. And now I need to change the name to test file too. here I say import java.io.print writer. Okay, I create a print writer. And then right here, I actually do not, this is input string. I actually right here, I say print writer output equals new print writer. Okay, right here I can do like file vb equals new file vb.text. Okay, and here I put I'm sorry, I put vb over here, right? And I print to the screen, but I also want to print to that actually my file. So here I say output.print line, and I say token, and then why I don't print token only, and after the token I put a dollar F signs to make a difference, right? So each time now I open a file called bb.text, and then here I actually, okay, normally I actually output to where? Normally I actually read in that file from AA, I put into the scanner called input, and input go to my file. This one's test file 2. And then here, I actually print to my out system.out, and then this one go to monitor, right? But now I add another one, that one called output, and then this one I go to a file called bb.text file. Okay, that's the way I actually trying to print now. So right here, I actually have the output. So I can actually do this, align to here. So it's actually one is the one output string and second output string. And after I finish the printing here, I say output.close. I close out the output string, and let me compile, and let's run. So from screen point of view, it actually is the same, right? And I go to my directory. Frame chapter 3, I actually found this BB. H1A with SI. I put that on purpose because you will know that actually is right out from here. So if I change this one to star, it will still be working. And this one actually I just close. Oh no, I actually open. Same file BB, right? Now change to star. Is that okay?
Yes.
So today actually I teach you what? Today I actually teach you
Input and output.
input. I have a keyboard. I input to my program, right? There's an input scanner, or I use the AA using another different scanner. Go to the file, go to the program, and then I can actually go into the system.out, print to my screen, or actually I can put into my output scanner, not print writer, and then print to a BB file. So you can actually, by doing this, actually you can do what? 2 by 2, totally 4 different ways. You can do this one to this one. You can do this one to this one, or you can do this one to this one, or this one to this one. Totally 4 ways of reading and writing, right? 2 kind of input, 2 kind of output. Totally 2 by 2. You have 4 ways to handle your input and output, right? So that's what we have for this this part. So now let's go back to our class. Okay, I did not follow the whatever material they have 100%, right? Because I don't want to mess up. I won't actually give you more information than just teaching this basic material. Now the next one is literal and constants. What's literal and what is constant? So here, let me go back to this test A. I would like to use another one. It's called test literal. So what is a literal? Literal are some numbers. So here, the static deployment. Okay, right here I have a copy function, and here I say it should be right, and here I have an integer a, and I can write like this one. This is this 2787382. That is a literal. Some words, right? I can have integer b equals then 0b 1111 1010. What's that? I'm sorry, 0b. What is that? This is a binary number. So if I don't do this, I do this. What is this number? Binary number. What's the value for this binary number? Do you still remember how to convert it? Hello?
Oh, hi.
Yeah, do you know how to convert?
36. Wait, no. Wait, 2, 4, 18?
You have 1010, right?
Yeah.
The first one is how much?
1. Oh, wait.
So it's actually a. You are about right. I know you are right. You know how to calculate, but you just miss a digit. It's a plus 2, right? So let's print now and see what happened. Right? It's actually 10. It's a plus 2. Is that okay?
Yeah.
Let's call literal. Now, if I actually have this 1101 0101, okay, then this is a string of long 0 and 1. I cannot even know how many digits it is. What can I do? I can actually put this, right? 23818, right? But if I don't have this, it's basically the same. So putting an underline or not underline is the same. So this actually underline help you to count how many digits they are, right? So let's call literals. Literal are some numbers, and this one's binary, and I can also have integer c equals 0x AAB1. This one is hexadecimal. Okay, so this C number is of this value, but you convert from hexadecimal to decimal, right? And if I say integer d equals 0, 7, 7, what is this number? It's called octal number. So it's not 77, it's actually 8 based. So 8 by 7 is 56 plus 7 is actually 63. So last one is 63. This one is not decimal number, it's octal number. Octal is base 8. Is that okay?
Yeah.
Octal is 8 base, and hexadecimal is 16 base. Binary is actually 2 base. These are all called literals. Okay, but here I can have I can have double E equals 35 point this, right? And actually I can here put a F means 14 floor, F means floor number. If I say double F equals this, and finally I put a D. That means D means double precision value. See that? So F means a floating point. But if you don't do it, what kind of number it will be? Actually, here I can also put a floor, right? This is wrong because it's double type. So I need to put a double over here. Then it's okay. If I don't have this, I should put a F over here. Then it's a floating point type. It's okay. See that? If I don't have that, even I have a floor type, it will fail. Okay. You have to do double. So the number is actually of double type. But if you want to have that as a floor, actually a floor type, you have to put an F over there. Then it's fine. Is that okay?
Yeah.
So these are all called literals. And what is constant? Constant is right here. Constant is right here. So you cannot do this. Cannot do this. Pi equals like 3.14. And let me print out Pi. Is that okay?
Yeah.
No, it's not okay. Because
okay,
you put a final means no change. And we say is the final is a constant. So I have to remove this one. It will get the value from the first statement. This one is okay. That's called constant. Constant means no change. You cannot change your constant. So constant actually means no change. Some variable that you cannot change it. Okay? And then here we have prompt. I think this is okay. And then you read data in and then convert the inches to centimeters. So this some value happen in program, we call it literals. And some number you don't want to change, that's called constants. That which has a final. The next one is a format of the output. Okay, I calculate, but this one is actually such a low number. So for example, the project you work on, right here, I told you, you have to put a double over there. Otherwise, the integer divided by integer, it will be integer division. You don't actually show the number of digits. But I put it into a double format. The program you wrote, actually, I put that double in, but if I run it, the number of digits is so long. I actually don't like that. What can I do? I actually don't like that to be that long. So in my program, instead of using println, I use the printf. And right here, I put percentage sign f. F means floating point number or double. I can have 10.3. And then I just basically put these together. And this one I need to escape it because the percentage has special meaning. Okay, and here I want to change lines. So I put this, and then I have comma, and then I copy this percentage of the day passed. Copy this over, and you will print out that in format. Why is that? Wait, let me put a single percent. Oh, that has an exception. So here I should percent. Right? So you got the 75 and then 3 digit over there. But actually, I don't want to be that wide. So I actually put 7. Let me put 7. 7 means what? 7 means my variable totally has 7 y, but here that 414 already taking 4. So at most, I have 3 more before the decimal point. So right here, let me compile and run. And I'll get this, right? I'll get this.
It's the same thing.
No, it's actually shorter.
Oh.
I used to put 10. It looked like the same, but actually it's shorter. I went wrong. This one's shorter.
Oh, okay.
See that one?
Yeah.
So this one's shorter. So that 7 is actually deciding the total width. And 3 means the, excuse me, 3 means the fractional part. So usually people don't use a 7.3. Usually people use 7.2 for percentage, right? Because you want it to be the hundreds when percentage is involved, right? Something like this. Is okay. So here I introduce you what? The literal, the constants. Now I formatted the output, right? Formatted the output. I had a So here, if I want to print, not printing this, and I want to print the number as an integer, and here, say all roughly, and then I put the d for integer. So here I should do this number, and this number I want to convert it to integer. So right here I put it, and in front of it I cast it to integer, right? And too long, so I cut to another line here, and roughly d%. So this d I put 5. So this would look like, wait, something wrong. So here I need to put %. Let me clean it. Right? So roughly 75%, but this 5 seems to be too long. I can put 3. Right? Is that okay?
Yeah.
So actually that printf statement is trying to give you some format. But if I do this, I put a minus sign in front of the things, in front of the 7.2%, 7.2f. So this f double percentage means 1 percentage symbol, because percentage is used for formatting. So here percentage, this one is replaced by this number. And this one so far to here is replaced by this integer number. And percent means percent. Percent means change line. Is that okay?
Yeah.
And I put a minus sign. When I put a minus sign, it actually is left justified. It actually is left justified. So compare this one to this one. This one actually moving the number more toward the left. So here has some empty space before the percentage, because totally I have 7.2. So 5, 6, 7, 7.2, but I align to the left. And this one I have 3. So here I have 2 number and then 1 space over here. But if I delete that minus, I delete that minus sign, it will be right justified. Right justified means it's aligned to the right. In that case, the numbers stay with the percentage sign. There's no space like this. It's actually space is showing here. So 1, 2, 3, 4, 5, 6, 7. Same thing here. The space moved to here. Is that okay?
Yeah.
So this part is called the formatted output. All right. So here I teach you percentage number f floating point. I teach you percentage d for integer, and basically these are the commonly used things. You have the decimal integer, you put the d. You have padded with 0. If you won't have leading 0, when will you need the leading zeros? For some application like your social security number, you cannot, if you have 0, 1, 1, you cannot say I'm 1, 1, right? Because I have a leading 0 in there, so I still want to print the leading 0. In that case, you put the 0, and all other number would be actually would add a 0 in front of it. So here, if I have 3, before 3, I put a 0. It becomes 0.75%. I actually pad it with a 0 in front of it. But that's not what we want, actually. I just show you how it works. But that's not what we want for padding. Is that okay?
Yeah.
So here are some formatting. You need to read these things. And then casting need to convert integer to double to integer. And I discussed this before. If you have a table, you need to care for about who can implicitly casting and who will not. Remainder operator the percentage. I discussed this before, right?
I think so.
The modular, so we put it.
Yeah.
Then we put things together. There's a conversion, and this conversion program actually is converting centimeter to inches, or inches to centimeters, and then inches to foot. So that's wrong. How many? That's 565 centimeter. So that's 2 foot and 2 feet and 1 inch. Okay, so this program actually has the centimeter per inch. What's this? That was the final. What's this? That's a constant. You cannot change it, right? And final integer inch per foot is 12. That's also an instance. And then here we have output and we have input. And then it's casting. I cast the number cm by cm per inch to inches. Okay, that's that. And there's a scanner box. And scanner box I seems to told you before, so I skip it. So this week, actually, the exercise, I would say you can do 1, 2, 3. Actually, you can do as many as you want. 1, 2, 3, 4, all of them. Is that okay? So this week homework is 1, 2, 3, 4, and then we will finish. And then you need to study this chapter as well. So work on this homework. Okay. Any question for today?
Wait, so my homework is all of it?
Yeah, all of it.
Okay.
Give you the maximum exercise.
Okay.
So you will learn faster. Is that okay?
Yes.
So chapter 3, we finished right here. Let me do this. I have this different program, right? Some are actually your homework. Now let me actually, for you, this homework, I just sent back to you. Your homework. This one, right? And who's a chapter 3? Chapter 3, you pretty much need everything. So what I would do is actually, let me actually zip it. And then I pick the zip file for chapter 3 for you. So you will see the examples. And then you will actually be able to work on yourself. Now, do you know how to download them and then put them into proper position location? Only you need me to guide you. Are you okay to download them and put to those files to work?
I don't think I know how to do that.
Okay, so now let me do once, okay? Let me show you once. So for example, I read this, have these 2 files over here, and I have a chapter 3, right? I download it, and I don't download to the same location. Let me download to another location. say I have this PC, I go to DC, and I here, Eric, and then let me download to, say here, TMP. Okay, my name and then TMP, I download to here, the zip file, right? And then after I download, I do show in folder. Is that okay?
Yeah.
So I show it in folder, and right here, I unzip it. So I use that PZ. I install the PZ on your machine.
Okay, thank you.
So you actually can extract it in TMP. All right, so I have a chapter 3 now. Let me bring up my project. I just want to make sure it work for you, okay? Now I actually open my project, and then I go to here, go to TMP, and go to chapter 3. And that there, I want to open this directory. And open, see, everything is in there.
Okay.
So here I can test file, right? And here actually I'm not doing on my directory. This one is different from this one, right? A different location. So same thing right here. If I, the one let me show you, actually this one I download the zip file, but this time I try to download, I'm sorry. This time I try to download this chapter 2 exercise, whatever it is. Okay, I put into this chapter 3 location, save there. So you download the chapter 3 first, save there, but here I haven't seen it, right? So here I actually reset Java virtual machine. And then actually I open project, chapter 3. Okay, let me close it. Okay. Let me actually close it, and then I reopen the project again. So that your homework file actually is in there, but I modified it already, right? So right here, I can also compile run. So now let's do this. Let me stop sharing my window, and then you operate once for me. You know, that's why I save some time. I don't want to continue my work.
Okay.
And then I stop sharing, you sharing, and then you download from where? From the one I show you, from this Facebook location, you can download that. Okay, I stop sharing and you share your screen.
Oh, okay.
Try to find the other one.
There.
So download the chapter 3 first.
Let me press.
And then show folder. Now you are in the download, right? You need to cut it and paste to somewhere else. Cut that chapter 3. Right mouse click and cut. Right? And go to this PC. And then see Windows C. Oh, I'm sorry, Windows D. Your machine is Windows D. Sorry. Go to, and go to data D. And Ashley Chow, okay, over there. And then you have J development, right? Under it. Oh no, this one is actually, no, this one's wrong. Go to Ashley Chow again. Okay. And one level up. Let me see. One level up. Java. Okay, this one is also not good. Okay, move back. So where did you put your file then? So here, let's go into the HD. Go to the HD now. Now here you open a right mouse click, new folder, and then say Blue-J. The new folder name change to Blue-J. Yeah, no, just Blue big J. No. Blue and J, Jack, J, yeah. No, just J. The character J, just like the software name, or capital J, please.
Okay.
And then you change into Blue J. Now you go into Blue J, and then here paste. Yeah, and then right mouse click, open with, pzip, and then extract. No, go to top. There's a extract button. Click that extract button, and then OK. Okay, and then close this pzip window. Okay, you have a chapter 3 there, right? Oh, done. Okay, stop. No, stop. You have that installed, right? You have that chapter 3 downloaded. Now, go to open your BlueJ editor.
Which one do I open?
What? No, your BlueJ. Now open project. Now you open your project. Open project. Go to D drive. Go to D drive. Yeah. HD. Yeah. And then go to BlueJ. Go click chapter 3 and then select folder. Okay. Okay, got it. Now you run anyone. How come this one doesn't finish? Wait. Oh, you actually waiting for you to key in. Okay, type 3 or 4, whatever.
I can't type it.
No, actually your window is too big. It's actually in the bottom of the line.
Huh?
Actually in the corner, your window is actually too big. You're typing something. Yeah. Okay. The window is really too big. You need to minimize it.
Okay.
Very smaller. Yeah, your window is really too big.
Okay.
Type 4.
Okay.
Yeah, okay, this is done. Now let's download the your homework file to this same directory.
My homework?
Yeah, your homework. The one I returned to you, not this one. No, not this one. Go to the Facebook.
Okay.
Facebook. Where is your Facebook? Yeah, here. And then message. Yeah, that one. Download. Okay. And then same thing, show in the folder. And cut. And go to your D drive. Yeah, that's okay. Ashley Chow. And then go to BlueJ. Go to chapter 3. Go to under chapter 3. Pass here. Yeah. Now, go back and close your chapter 3 window. Go back. No, go to BlueJ. Close your chapter 3 window because you didn't see that it closed it. And then pick another different BlueJ window. Whatever BlueJ window is, open project. And then select chapter 3 and select folder. And then compile and run. Got it? So now you download my file and then unzip it and do whatever. Now you return control to me. You actually don't share now.
Stop share?
Yeah, stop share. Okay, now let me this is your window. So let me see my window. Return to that. Okay, now actually, no, it's okay. Wait, that's your window. Let me see where it is now. So now, wait, I need to share window. Share my window now. Okay. Wait, what do I want to do? I actually put you had a homework. What I want to do now. Okay, now so you work on these two projects with 4 different projects, right? So now you learn how to download a file. So remember that you sign up my A course, right? And maybe later for B course as well. You go to here, now this is a teacher's view, so you don't see something like this. But you will see some view as a student, you will see something like this. So for example, sometimes you say over the year, if you do AP or something, you go to like this one demo program, right? Okay, whatever this course it is, right? Here I have some zip file. So whenever you watch my video here, right? And then you want to try out a program, actually you can just click this one, it download to, and it's a zip file. So let me put it in my temp here, right? And it downloaded the file here. I show in the folder. Here I actually pzip it, and let me use this one. Open with, and then here I extract it over here in my temp. And in my temp I have these things, right? And then this one actually, it's missing the project file, but it's okay. I copy my project file over. It's missing the project file, so Bluejay cannot read it. So in this case, I package file, I copy my package file over to this new one here. And it doesn't have the README file as well. So I come here, over here. I also copy the README file. README file, copy. Go back to here. Over here. Right here, right? And I finish. Then I actually, you can see my window, right?
Yeah.
Then I go Bluejay. And then I open project and to temp to this student with GPA or whatever. And then I compile and I run. Right? 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 Something like that. So what this show you is what? I show you two things now. Okay. This is actually, if someone send you some file, you can actually download and then put it into the right location. Besides, if you watch my video program, this one is for AP course, right? But we are not in here right now. We are actually in this bootstrap Java stuff. Okay, but later if you are going into that AP course and you actually have that course access, right? And then you go to any other video and there are some file you can actually download. You actually can also download this PDF file that actually is a node, okay, node slice. And then you can also download the code. You can actually try it, okay? Is that okay? So today we are up to here. Is that okay?
Yeah.
So basically, what do you learn today? Converting file from actually input and output.
Output, yeah.
And then literal and constants.
Yeah.
And then print with formats.
Uh-huh.
And then finally, how to download file, copy, and open the zip file.
Yeah.
Run it. Okay, you learn 4 things. And then now you work exercise on the 4 problem. Maybe you take work on 1 problem a day or something. Okay, try not to put everything into 1 day to finish. So every day work out a problem, maybe taking you 20 minutes or something.
Okay.
Is that okay?
Yeah.
Okay, now good night now.
Okay, good night. Thank you.
Bye now.